Okay, picking up with the review. This is part 3 of the review. Solve, graph, and give the interval notation. So here's the first problem. So what we do here is, for part A, is we get the x's on one side, get the numbers on the other. So subtract 3 from both sides, subtract 2x from both sides. And 5x minus 2x is 3x, greater than or equal to negative 9 minus 3 is negative 12. Divide by the number in front of x, divide by 3. Divide both sides by 3 to get x greater than or equal to negative 4. A couple of things to remember. Remember when we're graphing this, greater than a number goes to the right. So if I come to negative 4, here's 0, negative 1, negative 2, negative 3, negative 4. All the numbers greater than negative 4 would start on negative 4 and go to the right with an arrow. Now, remember, if it's greater than or equal, that means you're using the negative 4, and we put a bracket on that negative 4. Remember, if the equal to was not under here, we'd only put a parenthesis on the negative 4. Now the interval notation. The interval notation describes your graph from left to right. This graph started, the far left was negative 4. There is no far right because it goes on forever. Since it's going to the right, that's positive infinity. We'll put a bracket on the negative 4 because there's a bracket here. We never put a bracket with the infinity. Infinity always has the parentheses. Okay? Next one, almost the same. Get the numbers on one side, x is back on the left. So this would be negative 2x greater than negative 10. But remember, in inequalities, if you divide by a negative, you have to flip that symbol. So that's why that symbol got flipped. Negative into a negative is a positive. Negative 10, negative 2 is a positive 5, but you flip that over. Now, all the numbers less than 5 is everything to the left of 5 with an arrow. Parentheses because there's no equal to. When you do the interval notation, because the graph goes to the left forever, that's negative infinity. It will always go on the left side of the comma, and the biggest number on the graph is 5. Parentheses on both, because there's always a parentheses on the infinity, and the parentheses on the 5 because that's what's here. There's no equal to under here. All right, those two inequalities are what I just call regular inequalities. Now, these next two inequalities, they're inequalities, but they have a special name. These are called compound inequalities. The reason these are called compound inequalities, if you'll remember, in English, a compound word is a word made up of two words. A compound inequality is an inequality made up of two symbols. Now, how do we solve a compound inequality? You get the x by itself in the middle. Is the x by itself in the middle? No. You have an adding 3 here. How do we get rid of an adding 3 in the middle? You subtract 3 in the middle. But whatever you do to the middle, you must do to the right, and you also must do to the left. So I subtract 3 from the middle, subtract 3 from the left, subtract 3 from the right. When I do, the 3's add out in the middle and leaves just x. The left side would be negative 6. The right side over here would be negative 2. If I graph this, a compound inequality, I told you, is always located between your two numbers. So this is just simply everything between negative 6 and negative 2. So negative 6, 1, 2, 3, 4, 5, 6, and negative 2, negative 1, negative 2. So it's everything between those two. Why did I put brackets on both of these? Because of the equal to's. Also notice that there's no arrow, because if you put an arrow, that indicates that it goes on forever. And then the interval notation is just from negative 6 to negative 2. Never an infinity, never that infinity business when you're dealing with compound inequalities. This next one, almost identical to it. Right here, start out, get rid of this. You got it in the middle. It's a compound inequality. You got to get the x by itself in the middle. You got to get the x by itself in the middle. So what I do is to get rid of the subtracting 4. To get rid of the subtracting 4, you have to add 4 to the middle. But if you add 4 to the middle, you have to add 4 to the left side and add 4 to the right side. When you add 4 to the middle, the 4's add out and leaves just 2x in the middle. The left side, 2 plus 4 is 6. Right side, 6 plus 4 is 10. Now to get rid of the number that's in front of x, the 2, you divide by it. But whatever you divide the middle by, you have to divide the other two sides. So this would be negative 3 less than x less than 5. The x is now by itself in the middle, which means the inequality problem is solved. When I graph a compound inequality, the graph is always located between your two numbers, from 3 to 5. No brackets because there's no equal to's under here. Your interval notation is everything from 3 over to 5. Okay. Now this next problem, or next three problems. Solving equations. The equations here, there's two things you need to remember about solving absolute value equations. Number one, you have to get the absolute value on a side by itself. Number two, you have to memorize the formula that works it once you get the absolute value by itself. Okay, so for instance, in this first problem, there's the problem. Is the absolute value on a side by itself? Yes. So absolute value equal. There's nothing else over here outside the absolute values. Remember, what we do is we have to use a formula. The way we do this is, once you get the absolute value by itself, we call what's in here A, and we call what's over here B. And then there's the formula that we use to work the problem. A equal negative B or A equal positive B. So you would write 2x, A is 2x plus 3, equals negative 7, or A, which is 2x plus 3 again, equals just B, which is 7. So now we've gone from one equation to two equations. So I've got to solve each one of these equations. To solve this one, I have to subtract 3 from both sides. When I do, I get 2x equals negative 10, divide by 2 to get x equal negative 5. Here, subtract 3 from both sides. 7 minus 3 is 4. Divide by the 2 to get 4 over 2, which is 2. So this problem has two solutions. Okay, over here, absolute value equals. Step 1, get the absolute value by itself. It is. Now that's my A and that's my B. But remember, we said that if B is negative in this formula, there is no solution. Now I will quickly remind you why that was the case. Can you get the absolute value of anything and it ever be negative? No. The absolute value of anything is always a positive number. That's why we said if B is ever negative in these problems, you don't do any work at all. You just write no solution. Now, in this third example, if you are not careful, in this third example, you will say this is A and this is B, so it's no solution. That is not correct. And the reason is because the absolute value symbol is not on a side by itself. The first thing you have to do is get the absolute value symbols by itself before you identify A and B. So the first thing I've got to do is the absolute value by itself. No, it is not. We've got the subtracting 7 that we have to deal with. So what I've got to do first is add 7 to both sides to get the absolute value by itself. Then, when I do that, if B is positive, and it is, then we identify A and B, and then we use the formula A equal negative B or A equal positive B. And then solve each equation. So subtract 4 from both sides, you get negative 8, and divide by 3. Subtract 4 from both sides, you get 0, divide by 3, but 0 over any number is 0. So that is solving absolute value equations. Okay, from there we went to two-dimensional graphing. And I told you you need to be able to graph lines by doing two things. The first thing you need to be able to do is graph a line by using the intercepts. This is the way the problem will read. So what you have to remember is, how do we find the intercepts? Well, first remember there's two kinds of intercepts. There's an x-intercept and there is a y-intercept. Now, how do we find them? Here's what we do. To find the x-intercept, you let y be 0. So to find the x-intercept, we let y be 0. All right, so let's do that. Take 0 and put it in y spot right there. What's 4 times 0? It's 0. So all you're left with is 3x equal 12. Divide by 3 to get x equal 4. So 4 comma 0 is the x-intercept. You'll see why in just a second why that's called the x-intercept. Now, how do we find the y-intercept? To find the y-intercept, you let x be 0. So if I let x be 0 right here, 3 times 0 is 0. So I'm left with 4y equal 12. Divide by 4 to get y to be 3. Now, if you plot the point 4 comma 0, 4 comma 0 is right here on the x-axis. If you plot 0 comma 3, it's right here on the y-axis. That's why they're called the x and y-intercept. And then draw your line through those 2 points. Okay, this next one was find the slope and the y-intercept and graph the line by using those 2 things. Well, in order to do this, you have to remember first how to find the slope and y-intercept. This is what we call putting the line in slope-intercept form, which simply means solve it for y. So I'm going to take this problem and get the y by itself. So move the 2x over. And when I do, it becomes 3y equals negative 2x plus 9. And then divide by the number in front of the y to get the y by itself. Divide by 3. Divide by 3. Divide by 3 to get this. When we solve it for y, this is what we call the slope-intercept form of the line, or often written y equal mx plus b. So m stands for your slope, y equal m. So m is negative 2/3. The number on the end is your y-intercept. So how do we graph this now? We found the slope, we found the y-intercept. Now how do we graph it? First thing you do is you plot your y-intercept. So let me slide this over. So the y-intercept, right here, says the y-intercept's 3. Plot the y-intercept on the y-axis. Now, what did it say the slope was? It said the slope was negative 2/3. Now remember, by definition, slope is rise over run. So the rise is negative 2, the run is a positive 3. So I would come to my y-intercept, which is right here, and the rise would be negative 2, that would mean go down 2. The run is a positive 3, that would mean right 3. But you go down 2 and right 3 from the y-intercept. And you don't apply this negative to both of these numbers. Apply it just to the top. So down 2, right 3 from right here. So if I go down 2 and then straight over 3, that's where that point is, and then I can draw the line. Okay, and this next one. This next one, we're graphing, and this is real easy, but you have to remember something here. Remember, if an equation like this one up here, if it has x's and y's in it, the line is slanted. But remember, if you're graphing a line that has just an X in it, it's a vertical line, always. Just a Y, it looks like this. So if you graph X equal 3, it's going to look like this. So to graph this, you go over to where X is 3, 1, 2, 3, and draw a vertical line. So this is where number 1 is. Now, X equal negative 2, come to where X is negative 2, and draw a vertical line. Now, if it has just a Y, that's a horizontal line. So if it has just a Y, go up 4, where Y is 4, and draw a horizontal line. So this right here is the third one. And then Y equal negative 1, go down to where Y is negative 1, draw a horizontal line right there. That's number 4. So this is 4 different lines, 2 verticals and 2 horizontals. Okay, next 2 examples. Work the same. I'm not going to labor very long here. To find the slope of a line, if you know 2, now remember, you're only going to be given the 2 points. What you have to do is remember 2 things. Remember how to label xy, first point, xy, second point, and then your slope formula. Then it's y2 minus y1, which is negative 2, minus a negative 7. That's going to give you plus 7, over x2 minus x1, which is 3 minus 5. So negative 2 plus 7 is plus 5. 3 minus 5 is negative 2. Now you can leave it like that or put the negative out front. Same thing. Okay, this next one, same formula, just another example. So it's y2 minus y1 over x2 minus x1, which is 0 over negative 8, and 0 over any number is 0. Now remember, when you're doing this formula, if the bottom goes to 0, not the top, but if the bottom does, you write undefined. Okay? Now the last thing, and the key here is this. Find the equation. To find the equation, when you hear those 3 words, you always use, to find the equation of a line, you use the point slope formula. So, in this problem right here, you're given the point, you're given the slope, you call this x1, y1. Here's your formula, so you need to memorize it. Now it's going to be y minus, and then y1 is negative 4. So that's going to go plus 4. Equal m, which is negative 3, times x minus, and then x1 is 0. Distribute. Negative 3 times x is negative 3x. Negative 3 times 0 is 0. And then move the 4 over. Now, why did I do that? Because the instruction said, write the final answer in slope-intercept form. So in every one of these, I will solve it for y. Okay, this next one, not going to labor long here either. Here's your point slope. This is your x1, it goes right here. This is your y1, it goes right here. And that's your m. Double negatives gives you a positive. And then when you distribute, that's 5x plus 15. And then move the 1 across. So that one's just like the one that we just worked. Now, what makes this next one different is this. In this next one, remember the instruction said, find the equation of the line. Well, what did I say you use? Point, slope, formula. Do we know a point? Yes, we do. The problem is, we don't know the slope. So what we have to do in this problem, it's kind of like a problem within a problem. You first of all have to get the slope. So I call this one x1, y1, this one x2, y2, just like we did a while ago. There's my slope formula, and I plug these 4 numbers into the correct spot right here. And when I do, I end up getting m to be 2 over 5. So now I have my slope, and I have a point. Now you say, Mr. Reiner, which point do we use? It does not matter which one. However, since I've already labeled this one x1, y1, and that's what's in my formula, I'm going to use that. So this is going to be y minus y1 is 3 equals m, we just found it, 2/5, parentheses, x minus, and then x1, if you look right up here, is -2. Double negatives gives you a positive. Now distribute. 2 over 5 times x is 2/5 x. 2 over 5 times 2, this goes plus because of the double negatives. 2 over 5 times 2, that's the work you copied over here. 2 over 5 times 2 over 1, multiply straight across is 4 over 5. That's where this comes from. Now to get the y by itself, move the 3 over, becomes plus 3. And then when I do add these two numbers together by getting a common denominator. The common denominator between 5 and 1 is 5. So 5 into 5 is 1. 1 times 4 is 4. 1 into 5 is 5. 5 times 3 is 15 over 5, which is 19 over 5, which is where that comes from. So this is where that answer comes from. Okay, this next one, 2 more examples. Here's the problem. We're using the point-slope formula. Do we have a point? Yes, we do. Do we have the slope? We do not. However, since the line is horizontal, we know that the slope is 0. So I know the slope is 0 not because it told me that, but because it told me the line's horizontal. All horizontal lines have 0 slopes. Now I have the point, so I put this in for x1, this in for y1, and 0 in for slope. So it's y minus -7, which is going to be y plus 7, equals 0 times x minus 4. Distribute with the 0, it won't matter because 0 times x is 0, 0 times 4 is 0. So the whole right side goes to 0, so you get y equal -7. Now, it should not shock you that this has just a y in it, because remember, we said a while ago, when we were graphing, equations with just a x look like this. Equations with just a y look like this. So it doesn't shock me that this doesn't have an x in it. As a matter of fact, it's y equal whatever that number right there is. So you say, Mr. Ryan, I got a question. So if it's a horizontal line, will it always be y equal whatever that number is? Yes. So you can either put 0 in for the slope and go through it, or if you remember those facts, you could just go straight to the answer and write y equal whatever that number is. But you can only do that if you know the line is horizontal. Now the last problem. What did we say we use in every one of these problems? Point-slope formula. This is one exception to the rule here. Here is why. I cannot use the point-slope formula on this problem because it says that the line is vertical. Well, what's the big deal about that? If the line is vertical, it means that the slope is undefined. So, if the slope is undefined, what you going to put right here? I mean, I got what to put for the x1 and the y1. I got those two numbers, but you can't plug undefined in for the slope. I don't know what it is. So in this case, you have to remember this. If the line is vertical, which means the slope is undefined, that means your equation is going to have just an x in it, no y. So it's just the opposite of this one up here. So the vertical will have just an x in it. And if it has just an x in it, it's going to be x equal whatever the x number is. So in this case, the slope's undefined, it's a vertical line. It's going to be x equals some number. And in this case, it's x equal whatever that front number right there is, which is 4. So, this concludes the video for your review. And so, you can now practice on your problems and double check your work to see how well you are ready for the test.